Hi friends, welcome to Curie Electronics. Today we are going to solve ISAC 2016 Technician B Electronics question paper. So this is the part 1. So all of you please share the video with your friends. Also press the like button. So we'll start. So this is the first question. Fleming's left hand rule. Fleming's left hand rule is applicable to. What is the use of Fleming's left hand rule? Fleming's left hand rule. When a conductor is, see, this is a conductor. When a current carrying conductor is placed in a magnetic field, it experiences a force. So left hand rule is used to find the force direction. Force direction. Force direction. So here if we see, and the thumb shows the force direction, and the first finger shows the direction of the magnetic field, and the second finger shows the direction of current. So Fleming's left-hand rule is used to find the direction of force. This is used in DC motor. That is, in DC motor, the coil is placed in a magnetic field. So how the coil experiences the force? To know that, the Fleming's left-hand rule is used. Similar way, there is one more rule is there, Fleming's right-hand rule. Fleming's right hand rule. Fleming's right hand rule. This is used in the case of generator. This right hand rule is used in the case of generator to find the direction of the induced current. So we'll go to the second question. Second question, 5 cells each with an EMF of 2 volt and inner resistance of 0.5 ohm are connected in series. The resulting battery will have. That means there are 5 cells are there. One is our resistance. Again one more cell, resistance. Third cell, resistance. This is the internal resistance. Again the fourth cell, again internal resistance. Then now 1 2 3 4, again one more cell, again its internal resistance. So these all resistors are 0.5 ohm. 0.5 ohm is also 0.5 ohm, 0.5 ohm, 0.5 ohm, 0.5 ohm. Then what the resulting circuit will have? What is the voltage and internal resistance of the resulting circuit? If you measure here with a multimeter, what we get? That's a question. So here it is 2 volt, 2 volt, 2 volt, 2 volt, 2 volt. So this circuit we can replace this. If you see, these batteries are connected, these cells are connected in series. So this circuit can be replaced by one single battery, that is 10 volt, 0.5 ohm, 5.5 ohms. So 2.5 ohms comes, 2.5 ohm, 2.5 ohm. So the resulting battery will have 10 volt and 2.5 ohm resistance. This is a series circuit. This is a series circuit because the same current flows in the circuit. Circuit is open, so no current flow. So an EMF of 10 volt and an internal resistance of 2.5 ohms. So the answer is option B. Question number 3. The power factor of a DC circuit is always, the power factor of a DC circuit is always, what is the power factor of a DC circuit? It is always unity. It is always unity. For AC circuit, what is the power factor? For AC, power factor equal to reactive power, reactive power divided by apparent power. Apparent power. So that is equal to, it will comes to cos phi equal to reactive power, that is, we can take it as XL divided by impedance, cos phi. Okay, so this is a reactive power divided by the sum of active power and the reactive power, that is the apparent power. So this is for the AC circuits. So we'll go to the next question. Question number 4. The direction of current in an AC circuit. The direction of current in an AC circuit. Now see, if it's an AC circuit, it's an AC voltage. Similarly, if you have a load, similarly what happens if you have a load? This is for V. If you have a load, the same thing happens. The direction of is the current. We can say it's the current. It's the AC current. The direction is varies from instant to instant. So the answer is option C. Now for question number 5. Question number 5. 360 watt bulbs are in parallel across a 230 volt power line. That means there are 3 bulbs are there. There's a second bulb. There's a third bulb. And this is connected to the 230 volt AC. 230 volt AC. This 230 volt AC is the RMS value always. Okay. This is the RMS value. Now, what is the question? 360 watt bulbs are in parallel across 230 volt power line. If one bulb's burnout happens, so one bulb's got fuse or it's burned out. That burns this bulb, we can remove it from the circuit. What happens to the remaining one? What happens? That's a question. There will be heavy current in the main line. No, it's wrong. Rest of the 2 bulbs will not light. All 3 bulbs will not light. Other 2 bulbs will remain glowing. So the answer is option D, because see, if this is got fused, the remaining are nothing happened to the remaining 2 bulbs. Question number 6. If 120 coulomb of charge passes through a conductor in 60 seconds, the current in the conductor is, what is current? I equal to dq by dt. Q has given, dt also has given. What is the value of Q? 120. What is the value of T? 60 seconds. Now I we have to find. 12 by 6, 2. So 2 amps of current flows in the 2 amps of current flows in the conductor. Question number 7. If the capacity of a battery is 2800 milliAh, it can supply 1.4 ampere current for. The capacity of battery is given as 2800 milliAh. This is equal to what? This is equal to, if you divide by 1000, we will get in amperes, ampere hour, 2.8 Ah. So the battery is 2.8 battery. That means 2.8 amps it can supply for 1 hour, which equal to 60 seconds, 60 minutes, 60 minutes, okay, 60 minutes. So 2.8 amps the battery can supply for 60 minutes. So So the question is, how long the battery can supply 1.4 amps? That is double of this. That is 120 minutes, because we are taking we are drawing only half of this current. So it can provide 120 minutes. The answer is option C. Question number 8. The percentage of voltage regulation. The, for a power supply, the voltage regulation is given by V no load divided by V full load divided by B full load. The answer is option A. Question number 9. When maximum power is transferred when? This is based on the maximum power transfer theorem. Whenever the impedance of the source, see, we have a source, we have a source, we have a source, and we have a load. ZS is the source impedance, ZL is the load impedance. Whenever Z equal to ZL, ZL, ZS equal to CL. At this condition, maximum power transfer occurs. That is, whenever load impedance equal to source impedance, maximum power is transferred. Question number 10. In a step up or step down transformer, electrical power is transferred from one circuit to the another circuit. Option voltage, option B current, option C frequency, option D capacitance. This voltage, current and capacitance varies when you step up or step down a voltage, AC voltage, but frequency remains same. So the answer is option C. Question number 11. The peak value of a sine wave is 200 volt. Its average value is, see, the peak value is given. V peak, what is the peak value? It is 200 volt. I have made a video for the peak value, average value. You can see that video. So this is the peak value. This is called P peak. And from here to here, that is both maximum in the negative direction and maximum in the, this is V peak to peak. Now peak value is given. What is the average value? V average is equal to 0.637 multiplied by V peak. This will give the V average value of an AC sine wave. So 0.637 multiplied by 200. What it gives? That is 63.7 multiplied by 2. 2 7s are 14, 7, 12. 127.4 volt. Answer is option A. Question number 12. The input of an AC circuit having power factor of 0.8 lagging is 40 kVA. The power drawn by the circuit. So the power equal to VI multiplied by 0.8. What is the voltage? Voltage equal to VI he has given 40 kVA. So 40 kVA multiplied by 0.8, the power factor. So it comes to 4 8s are 32. 32 kilowatt. 32 kilowatt. So the answer is option C. Question number 13. Windows. What is Windows? Windows is a operating system. Then programming languages. What are some examples for programming languages? That is C, C++, C Sharp, Java, etc. Database. Database means there are some programs which are SQL. SQL is a database. Similarly, MySQL also a database. To store the database, these programs are used. Okay. Question number 14. Which topology is used for a central network controller? For a central network controller, star topology is used. That is, from a center it will connect to different nodes. That is what? Star network. Question number 15. A forward potential. Question number 15. A forward potential of 10 volt is applied to a silicon diode. A resistance of 1 kilo ohm is in series with the diode. The current through the diode is. So the question is, there is a diode, also a resistor of 1 kilo ohm in series with the diode, and that is powered by a 10 volt supply. 10 volt supply. This is the circuit. And also he is telling it is a silicon diode. Okay, he's saying it is a silicon diode. For silicon diode, so diode is a silicon diode. For silicon diode, there's a voltage drop of 0.7 volt. Now, we have to find what is the current through the diode. To know that, we can redraw this circuit like this. 10 volt are supplied. 10 volt are supplied. A diode can be replaced by a 0.7 volt battery source. Then we have, okay, this is 10 volt, 0.7 volt, and 1 kilo ohm resistor. What is the I we have to find through the circuit? Now we'll apply the Kirchhoff voltage law. So I will always start from negative to positive. If you have doubt in Kirchhoff law, you could watch my video on Kirchhoff law. You should have good practice. You should have good control over Kirchhoff law. So I will write minus 10 plus 0.7 plus I multiplied by 1 kilo ohms, that is 1000 ohms, equal to 0. 1 kilo ohm only will take it. 1 kilo ohms is better. We don't need to write see, whenever you have problems like this, keep always voltage in V, current in milliamps, resistor in kilo ohms. Then you need not to write the units. So if you add, we'll get 0.9 minus 9.3 plus 1I equal to 0. So what is I? I equal to 9.3 milliamps. I comes to 9.3 milliamps. So the answer is option B. Question number 16. A transistor has a typical value of beta 200. The collector current is 15 milliamps. Then base current will be. We have to find the base current. What is the collector current of a transistor? IC equal to beta IB. So IC we know 15 milliamps. What is value of beta? 200. IB we have to find. Now IB equals 15 milliamps divided by 200. This we can write it as 15 divided by 2 multiplied by 10 to the power 2. So 15 divided by 2 equal to 7.5. When you bring this 10 to the power 1 divided by 10 to the power minus 2 equal to 10 to the power minus 2. So which equal to 0.00. What happens? No. 15 divided by 2 equal to 7.5. Okay. 0.075 milliamps. So this is the answer. Option C. See here we have 1 divided by 100. So 0.0, one more 7 will come. Then 0.075. This will check it once more. 7 point, it's correct only 7.5. What is 10 to the power minus 2? 0.01. So when you multiply, we should have decimal we should have 3 digits. So it is 0.0075. Sorry, 0.075 milliamps. Question number 17. So friends, please press the like button and share the video with your friends. Which of the following option is true for FET? FET is a bipolar device. It's false. FET is a unipolar device. Low input impedance. No. FET will have high input impedance. It's a current control device. No. It's a voltage control device. But it operates with majority carriers. That is why we call either P-type MOSFET or FET or N-type FET. Question number 18. The efficiency of a class B push-pull amplifier is? The answer is option D. They say 78.5%. So it is in between 75 and 80%. Question number 19. An op-amp as voltage follower has a voltage gain of. So op-amp voltage follower circuit looks like this. This is the inverting inverter. That's the feedback from the output. This is the voltage follower input. This is voltage follower. Voltage follower. The gain of the circuit is unity. Answer is option C. Question number 20. Which of the following is a resistive component? LED, photodiode, LDR, SCR. So answer is LDR. That is light dependent resistor. Light dependent resistor. That's what LDR. LED means light emitting diode. Photodiode means it collects the light. When diode is forward biased, it is equivalent to see, when we have a diode, assume that's a ideal diode. When it is forward biased, it acts like a short. Anode and cathode. So anode and cathode acts like a short. If it is reverse bias, an ideal diode reverse bias, what happens? When it is reverse biased, when it is reverse biased, it will act like a open circuit, anode and cathode. So it is, so answer is as an on switch when it is forward biased. Question number 22. 555 ICU used to make. The answer is oscillator, making oscillator. This can be used to make one shot also. One shot means we will get an output like this. One pulse will go one shot, or one shot. So this timing, this will have a timing. This timing is given by 1.1 RC. So one with one resistor and one capacitor, you can set the timing of on time of this pulse. Question number 23. The device used for voltage regulatories. The answer is option B, Zener diode. I will try to make one video on Zener diode and some problems. Zener diode and some problems. Question number 24. Question number 24. A capacitor and coil in a parallel. Now see, this capacitor and one inductor is connected in parallel. This circuit is a tuned circuit. Okay, this circuit is a tuned circuit. The answer is option A, because this circuit is used to tune to different radio channels in a radio receiver. So the answer is tuned circuit. Question number 25. Light travels along optical fiber by. The light travels through optical fiber by. See here in the option A, refraction, option B, reflection, option C, scattering, option D, total internal reflection. So the answer is total internal reflection. Here reflection, if you write, it is wrong. Okay, this is wrong. So always read the question completely. Then only you should answer. Question number 26. PCM stands for. PCM stands for pulse chord modulation. Question number 27. 27. Question number 27. This is the De Morgan's theorem. A or B whole complement equal to what? Which equal to A complement and B complement. Similarly, A and B whole complement equal to A complement or B complement. So the answer is option B. This is the De Morgan's theorem. Question number 28. The decimal equivalent of binary 1, 0, 1, 1, 1. Now I'll write the position values of this. This is at 2 to the power 0. It's 2 to the power 1. This is at 2 to the power 2. 2 to the power 3. 2 to the power 4. So this 0, this which equal to, now we have to find. Now I'll write 1 multiplied by 2 to the power 4 plus 0 multiplied by 2 to the power 3 plus 1 multiplied by 2 to the power 2 plus 1 multiplied by 2 to the power 1 plus 1 multiplied by 2 to the power 0. 2 to the power 4 equal to 16 plus 0. 1 into 2 to the power 4 equal to 4 plus 2. Any number to the power 0 equal to 1. So 1 multiplied 1 equal to 0. Now 16 plus 4, 20, 22, 23. 23 to the power base 10, 20 to the power 23 to the base 10. So the answer is option C. So friends, if you need any particular topic to understand or to study, please ask in the comment section. So I'll make a video on it. Also, please share the video, press the like button, press the notification bell icon also, so that you will get the notification of new videos. Now question number 29. Parity bit check is used to. Parity bit check is used to. This parity bit is used in detecting one bit error, but it cannot correct. Okay, it will detect only it can detect the one bit error. It can be, there are two types of parity bit also, odd or even. Question number 30. So this is the last question today. So all of you, okay, we will see the question. Number of control lines required for 16 to 1 multiplexer. One multiplexer means what? That's mux means many to one, many to many to one. Now 16, what is the question? 16 bit. It's a 16 bit. It's a 16 is to 1 multiplexer. That means 16 inputs are there and one output is there. So here, it's not coming properly. Let me draw it once more. Okay, it's better. So we have 16 inputs. That is 1, 2, 3, 4, like that. Up to 16 are there. That is I0 to I0, I1 up to I15. And we have one output. This is what? Many to one. This is the output. Now we should be able to select out of the 16 inputs whatever we need. To select that, how many select lines we need? That is 4 select lines. S0, S1, S2, S3. So we need 4 select lines to select. So the answer is option C. See, 2 to the power 4 gives 16 combinations. So using 4 select lines, we can select any input out of these 16 inputs. Okay. So friends, thanks for watching. Please share the videos with your friends and please press the bell icon. If you have any doubt, please put it in the comment section or WhatsApp me. Thanks for watching. Thank you.